We have some quick work to mop up the content review for Module 2. What you're seeing here is the study guide addendum, the last part of the study guide addendum from Module 2, where we talk about the solution and how there are simulator errors and root causes. So what we've learned to date are the differences between a standard canonical representation of a Boolean function, and we've learned about a reverse canonical expression, how you take the outputs of a compound logic gate where the output is 0 or false, and how those are represented through reverse canonical expressions. So last week we explored the use of truth tables and canonical expressions. And all of this becomes a part of the stage that we set for a successful solution. So this week, what we're going to do is review the drawings that students submitted. We will do that on Wednesday. So what's happened is that not everyone in the class has submitted their drawing yet, and we want everyone to have a chance to do that. So for a one-time extension, I'm going to send a reminder to those that haven't submitted their logic gate drawing at this time, that they have one last opportunity to submit a logic gate drawing. And after review of that logic gate drawing, there may be some refinements suggested, right? So students will get a chance to resubmit their logic gate drawing. I'm talking explicitly about assignment 2.1. Can everybody see the screen?
Yeah.
So in assignment 2.1, essentially folks were supposed to draw their own diagram and then submit their own diagram. And then what we're going to do is, once everyone has turned in a drawing of their compound logic gate, as a class, we'll walk through a review of those drawings and offer suggestions or adjustments. So what are we saying? On Wednesday, once we get all of the drawings from students who intend to participate, we're going to, and by the way, if you think this is optional, it's not. The drawing that you submit for 2.1 becomes the first step of your solution. So once again, you're actually earning twice the credit for your first drawing, because after we review them together in class, each of the drawings will be anonymized. That means we're not going to include names or attribute ownership to anybody, but we're going to walk through those drawings together to appreciate the creativity and to offer, suggestions to enhance the drawing or corrections to make sure that the drawing is correct. Now, everyone that's in attendance on Wednesday needs to take note of that. That's going to be a recorded session. And what you're going to want to do at that point in the recorded session is take note of any suggestions for improvement or corrections. And then you're going to revise your drawing and then resubmit your drawing. So because this is a 2-point assignment, you're basically making sure that you've met all the criteria and everything's correct and everything's good to go. And so it's not uncommon in the first submission in the first round for students to miss a criteria. Oh, they meant to include a line for the W1, they meant to do this or meant to do that. And those are simple things, right? So we're going to refine what we review on Wednesday. Every student will have an opportunity to refine their drawing is needed, and then you're going to resubmit your assignment for 2.1, but that becomes the first step, and you receive additional credit for that drawing in your solution. The solution is worth 5 points. It's worth as much as your assessment. And the first step of the solution is to create a drawing of a compound logic gate. You're going to use the same logic gate. Okay. The other thing that I would like to share with you at this point is that if you're feeling ambitious, it's okay to do more than 2 logic gates, but as a general rule, it's not the best idea the first time around, because it's a bit like saying, oh, I don't need a bike with training wheels. I know I've never been on a bike before, and I don't need a helmet. And so we get some incredibly creative and elegant drawings, which would be great to use for Module 3. It's not a wasted effort, not at all. But for this effort, when you're creating your drawing the first time, just take two different logic gates, no more than 3, and you know, keep it a very basic drawing. And then that way, when you're working the solution, you have a much greater chance of achieving success with your first attempts of the solution. The more complex the diagram, you know, and the more elegant the diagram, certainly you'd earn more credit on the submission 2.1, you know, the submission for 2.1. But it comes back to haunt if you're not careful for the solution. So to take the drawing in a very deliberate and intentional process, through a deliberate process, is really important here. So everyone needs to complete the drawing. I have not received drawings from everyone. It is a mandatory assignment and is required for you to be able to complete the solution, which has not even been posted yet. And so we're going to review these together, refine them, resubmit them, then the stage is set for solution. Are there any questions about what we've just shared? Comments, observations, or questions about what we've just shared? Okay. What I'd like to do now is go ahead and call out the 2.2 assignment. So what we want you to do is to practice working with some examples where you work up the truth tables and the canonicals for a set of solutions. And what you want to do is download the functions truth table document first and work with that. Now, after you do this, you're going to check your answer with the key. The goal here is to give you what you need to put your understanding of how this works through the paces, right? We need you to practice with truth tables, with diagrams, with canonicals, before you get into the HDL simulation environment. If the goal is to learn how to build with your own hands digital components, then we have to make sure the concepts and the knowledge that you're working with is sound. And if we don't do that first, then working in the HDL simulation environment gets to be frustrating. So what we're going to do today is take a look at the first example, get started, and then I'm going to turn you loose for the rest of the class to complete the functions and truth table assignment. But I want to ask you not to simply read the answer key first and then do it. What you want to do is try to work this up on your own and then see how what you did tracks with the answer key. You do want to submit a correct set of answers for the assignment. When we look at this assignment, let's see. Basically, what we're doing is starting with two different inputs, right? And one of the inputs is knotted for an AND. So an AND logic gate, or the AND Boolean operator, receives two inputs. The A input at the top is knotted. And what we want you to do is to create the truth table, then compile the canonical expressions. Now, when we say compile, we mean we want you to determine, does it make sense for a standard canonical statement, or does it make more sense to do a reverse canonical statement? If you're joining us in progress and you don't know what that means, we covered that in a previous class last week, and all you got to do is review the video about that. It'll be labeled canonical in the resources folder. Once you've finished this, check your answer key. Make sure that what you did was correct before you go on to the more complex examples. Yeah, everyone? Now, here's a spoiler alert. This is a spoiler alert. This Boolean function, or complex logic gate, right? Compound logic gate, has more than one operator, and there's an order of operations, right? There's actually an order of operations for each of these. There's an order of operations where you have to do a specific thing first, and in order to work the solution correctly, work the answer correctly, you have to be able to first AND inputs R and S, and then OR that output with the Q input. It might help to draw a diagram. So when you're looking at solving problem 2, all of these might help to draw a diagram. That's a great way to practice drawing your logic gates. So I would suggest that you draw the separate, you draw an and then you put the not on the A input, like we showed in class on Friday. In this case, you're going to have the AND first with R and S inputs, and the output of that AND is going to feed into an OR, and the OR has a second input called Q. So you have two logic gates strung together. The first one's an AND, the second one's an OR. The output of the AND feeds into the top of the OR, and the bottom of the OR is the Q input, right? So that's what you're drawing and labeling. And then for problem 3, it gets more interesting as you get along. So take it a step at a time, go back to the answer key after you've done it, make sure your stuff is correct. You need to do all 3 of these and submit all 3 to log credit. I am not scoring these for you. I'm giving you the answer key so you can check your own work. Now, if you run into a snag, all you have to do, and you're scratching your head and you still can't get it because it's just, it's so different. That's normal. I want everybody to understand that that's a normal experience in this class. That doesn't mean that you're not going to do well in the class or that you don't have a mind for computer architecture. What it means is that you're a human being and then you're experiencing the same thing that human beings experience when they're doing something completely different, and you have to unlearn certain habits or work in a totally different manner, right? So I want you to understand, if you get that sinking feeling, just don't give in to that sinking feeling. Send me an email and say, hey, you'd like my help to walk through an example or 2, and we'll do that. We'll do that one-on-one. I'll be happy to do that one-on-one with you, and you have through the end of the week to complete this assignment and then the solution, and then you'll be finished with the module assessment by Friday. Okay? By Friday. Are there any questions about what's expected today for our, I'm trying to get my screen back here. Where is my, I'll stop sharing. And does anybody have any questions before we turn you loose to work on your stuff separately?
No questions from me.
All right. So let's use the time in class, right, to finish the drawing and then to take up. So if you haven't yet finished your drawing, we need you to do that now. At the end of today, I need to be able to take all of the drawings together, work with them to anonymize them, and then get them ready for the review on Wednesday. You need to start working on this assignment so that you have a strong sense of confidence by the time you finish this assignment before you engage the solution. As we come off of the solution, as we come off of the review of drawings on Wednesday, if you have done this by the time we finish Wednesday, you'll be in a good place to complete the solution and to take your first attempt of the Module 1 assessment. Okay? So any questions before any comments or observations, questions before we close today? One last time. Going once. Going twice. Thank you for tuning in. We'll see you Wednesday. We look forward to reviewing our drawings together on Wednesday. Have a good day.
You too.